So the question is on the binomial, it's asking me to use tables. Here we got a binomial distribution of 20, 0.4, and it's asking me then to find, correct the three decimal places, the values of equal to 5, between 4 and 12 inclusive, and greater than 8. So let's locate where I'm going to find this in the table first of all. Now 20, 0.4, that's telling me that n is 20 and p is 0.4. Now then on the tables you see the values of n coming down the side here. N is 2, 5, 10, 20, 50, and p is 0.4, the probabilities, the values of p are along the top. Now on this particular page the probabilities are only going from 0.01 up to 0.09. Now I wanted 0.4, so I won't find the tables I need for that distribution on that page. So if I go to the next page, okay, then I got n is 100 there, so again that's not what I want n to be 20. And then in the lower half of the page here, again I got n is 2, 5, 10 or 20. 20 is what I wanted, and the probabilities now coming across 0.1, 0.15. I want probability of 0.4, and there it is there. So the n is 20, probability of 0.4. So the part of the table that I am looking for this particular question are these values here. Okay, so n is 20, p is 0.4, and then I just got a list of numbers underneath. Now then, the tables that we are using are the tables of R or more. It tells me here in the writing, okay, the table gives the probability of obtaining R or more successes. Okay, so what's happened here, right, to get these values here, okay, we'd have a distribution table. Okay, where x could be anything from 0 to 20. And then the probability that x equals these values are underneath. Now then, but when I read from the table here, for example, say I picked out 10. Okay, so if R is 10 there, going across the table where R is 10, I get an answer. That answer is showing me, the table is showing me when R is 10, I got a probability of 0.2447. Okay, so table shows me 10, 0.2447. What that is actually telling me, okay, is that the values of 10 or more, because remember the tables are R or more, so 10, probability of 10 or more is 0.2447. So what it's done is taken all these probabilities separately and added them all together, and I got an answer of 0.2447. Okay, so that's what the value in the table is actually telling me. Now then, what the first question we had here was that find the values, find correct the values of probability x equal to 5. Now then I want x equal to 5. So to get x is equal to 5, and I want just that single value there. Okay, but of course the tables won't show me that single value. If I look up 5 in the table, 0.9490, Okay, 5 reads as that. Well, what that means is that plus that plus that plus that plus that plus all the ticks from 5 all the way up to 20 is 0.9490. Now if I only want 5, if I then look up 6, okay, and 6 is telling me 0.8744. And when I look up 6, okay, then what I'm doing is all those values there total 0.8744. And what I've just done there is that all those values total 0.9490. So if I want the probability that x is equal to 5, then I just subtract those two values. 0.9490 take away 0.8744, and the calculator will give me that's 0.70746, and the question asks me for 3 decimal places, so that'll be 0.075. So that's part A. And part B is asking me between probability that x lies between 4 and 12. Oops, 4 less than equal to x less than equal to 12. So we'll mess that up. Probability 4 less than equal to x less than equal to 12. And again, if we think in the table here, okay, so we've got all those values there. If I want it between 4 and 12, I want 4 up to 12. So if I read what 4 is in the table, I get all those values added together, and then coming to the line here, I want to include the 12, so then I have to look up 13 to see what those total, and then when I subtract them, I'd be left with values from 4 to 12. So in my table, I need to look up, to get that, it'll be the probability that x is greater or equal to 4, all those added, take away the probability x is greater or equal to 13, and then I'd be left with the values from 4 up to 12 inclusive. So I can use my table. I've highlighted the section that I'm on. So greater or equal to 4, so I come across at 4. Okay, and that, remember I lined up, I've highlighted here, it's lining up with a 0.4 because that was my distribution, 20, 0.4. So when I look at 4, it's 0.9840. 0.9840 represents all that value. Take away, and then I look up 13, I got 0.0210. Take away 0.0210, which is that amount, and then when I subtract them, I'll be left with what I want from 4 to 12. That gives me 0.963. and that is the 3 decimal places, so that's the probability between 4 and 12. Okay, I say this is using tables. Okay, if the question tells me I've got to use tables, and this is the method I'm using. If the question doesn't tell me I've got to use tables, then I can calculate all the values from 4 up to 12 and add them together. Okay, the third part of this then is x greater than 8. So the probability that x is greater than 8. Now greater than 8 doesn't include 8. If it's more than 8, it's got to start at 9 upwards. Okay, so I want those probabilities there from 9 upwards. Well, reading 9 from the table, that's exactly what the table gives me. All those values from 9 upwards. So I go back to my table, go across at 9, and I got 0.4044. So that's x more than 8 is the same as x greater or equal to 9, which is what I'm reading. I'm reading 9 in the table, 0.4044. Okay.